In this video, we're going to learn how to calculate a paired samples t-test. We're going to cover why we need to compute a t-test, the 4 steps in hypothesis testing, calculating the t-statistic, interpreting the t-test, and writing up our results. In this example, we have baseline and follow-up scores for patients in a hospital that are participating in a smoking cessation class. These 10 subjects are going to be participating in a smoking cessation class over the next 7 weeks. About 1 week before they started the class, the health educator gave them a survey and asked them the number of times they had smoked in the past 3 days preceding the survey. So we can see with patient 701, they reported smoking 11 times in the past 3 days preceding the baseline survey. And subject number 990 reported smoking 4 times in the preceding 3 days prior to the baseline survey. These participants went through this smoking cessation program for 7 weeks, and approximately 30 days after the last session, the health educator gave them the same survey, asking them the number of times they had smoked in the past 3 days preceding the survey. So the follow-up data show that patient number 701 reported smoking 9 times, and patient 202 reported smoking 10 times. You can also see that for many of the participants in the smoking cessation program, the number of times that they report smoking went down, while others report smoking more after the end of the smoking cessation program. So given that we have baseline and follow-up data regarding the smoking behaviors of participants in a smoking cessation group, we may want to see whether or not there's been a decrease in smoking. What we could do is we could examine the sample means for each group. So we could calculate the sample mean for the baseline scores for each participant. And if we were to calculate the sample mean at baseline, we would see that's equal to 8.30. And then we could also calculate the sample mean for the follow-up scores. And we would see that that is 7.20. So what we can see is that at baseline, the average participant smoked 8.30 times, and at follow-up, it was 7.20. Now, one of the issues is that these sample means are merely estimates of the population mean. They are not actually the population means themselves. So you'll recall that mu is the population mean and x bar is the sample mean. These sample means are estimates of the mu for each group. So this particular estimate of the baseline scores could be good or it could be bad. The same with the follow-up scores. So the fundamental question we have to ask is this: what is the probability that the difference between the baseline and follow-up scores is simply due to random variation? If we did have the population means, we would never need any inferential statistics. We could just look at the differences between the population means. As always, we're computing the sample means based on sample data. So we always have to ask the question, what is the probability that the difference between these two means is due to random variation? We also call that chance. We will compute a paired samples t-test anytime we want to look at the difference between two means that are related. In other words, each participant's baseline and follow-up score is paired. That is, the baseline and follow-up scores for each participant are related because they come from the same subject. So other examples of where we might use a paired samples t-test is where we have each participants providing a pretest and post-test score, or a time 1 and time 2 score, or in some cases we might have two means that are related simply because the scores come from, let's say, mother and daughter, or father and child. Most of the time, however, in public health, we're going to be dealing with baseline and follow-up scores, or pretest and post-test scores. Anytime we want to compare two means that are related to each other, we have to calculate a paired samples t-test. This test is going to tell us whether or not the two groups are statistically different from one another. We simply can't look at the sample means and make an inference because we always have to ask the question, what is the probability that the effect we see in our sample data is simply due to random variation? Another way of saying that is, what is the probability the difference between the two means is not zero? Given that we're looking at a ratio between the difference between the means given how much variability they share, it's important that we look at the theoretical underpinning of the t-test. You can see in the first figure where we show two distributions and their means noted in the dashed lines that there is a medium amount of variability in each of the two groups. And we can also see that because there's some overlap between the two distributions, that they share some of the same scores. But below that, in figure 2, we see where there's high variability, and the two groups almost look identical to one another, even though the means in the second figure are the same exact means in the first figure. In this case, the distributions with high variability share many, if not all, of the same scores. However, in the third figure, we see two distributions with the same exact means as above, but in this case, they share very little of the same scores. These two groups look very different from one another. It is this last figure that we are hypothesizing, that there's a difference between these two groups. Even though the means are all the same in each of the three figures, the distributions look vastly different from one another. So the research question we're asking is, has there been a decrease in smoking from baseline to follow-up? We're going to hypothesize that the number of times in the population that someone smokes is greater than the average number of times they smoke at follow-up. Of course, the null hypothesis is going to say there's no difference between the two mean scores in the population. So the first thing I like to do is go ahead and make a number of columns. The first column I'm going to make is going to be my subject column, and then the next column I'm going to make are going to be my baseline scores, and then the third column I'm going to make is going to be my follow-up scores. And so what I'm going to do is I'm going to write in each subject's number, the number of times they smoked at baseline, and the number of times they smoked at follow-up. So subject number 701 smoked 11 times at baseline, and then after the program was over, they smoked 9 times. And then subject number 202, they smoked 12 times at baseline, and then 10 times at follow-up. And then subject 313 was a 7 and a 3. Subject number 134 was 13 at baseline and 10 at follow-up. And then subject number 545 was 9 at baseline and 11 at follow-up. Subject 356 was 7 and 7. Subject 107 was 10 and 9. And then we have subject 867 was 4, and then at follow-up was 6. Subject 530 was 6 and 4. And then finally subject 990 smoked 4 cigarettes at baseline and 3 at follow-up. So the only reason I'm putting these subject numbers in here, these unique IDs, is because each person's baseline and follow-up, or time 1 and time 2 scores, have to be on the same line. So I've got all 10 of my subjects. I have their baseline scores as well as their follow-up scores. Well, the first thing that I want to do is I want to make another column representing the difference between the baseline and follow-up score. So I'm going to label that D for difference. So if I take 11 and I subtract 9, I'll get 2. 12 and subtract 10 is 2. 7 minus 3 is 4. 13 minus 10 is 3. 9 minus 11 is going to be a negative 2. 7 minus 7 is 0. 10 minus 9 is going to be 1. 4 minus 6 is going to be a negative 2. 6 minus 4 is going to be 2. And 4 minus 3 is going to be 1. Now I have a column of the different scores. The next thing I'm going to do is I'm going to make a column of the different scores squared. So what I'm going to do is take each value here and square it. So if I take 2 and I square it, I'll get 4. 2 squared is 4. 4 squared is going to be 16. 3 squared is 9. A negative 2 squared is 4. 0 squared is 0. 1 squared is 1. A negative 2 squared is 4. 2 squared is 4. And 1 squared is 1. So now I have the column of my different scores squared. The next thing I'm going to want to do is get my sums for each one of my columns. So I'm going to get a sum of my baseline scores. So if I add these all up, I'm going to end up with 83. If I sum up all of the follow-up scores, I'm going to end up with 72. If I sum up all the different scores, I'll get 11. And then finally, the sum of the different scores squared is 47. One of the first things I like to do is I'll go ahead next and calculate the average for the baseline. And you'll remember that to calculate the sample mean, it's the sum of the scores divided by the number of scores. So in this case, for baseline, the sum of the scores is 83 divided by 10, and that will give me a sample mean for baseline of 8.30. Now I'll do the same for the follow-up scores. In that case, the sum of the follow-up scores is 72 divided by 10, which will give me a mean at follow-up of 7.20. Once I have the means for both time 1 and time 2, or in this case baseline and follow-up, now what I'll do is go ahead and get the sum of the difference scores. And we can see that we have that here, so the sum of the difference scores is 11. And then I want to write down the sum of the difference scores squared, which is this value here, 47. And then the next thing I'm going to want to get is the average difference score, or D bar. This is just going to be the average of the difference scores. So if I take 11, that's the sum of the difference scores, and divide it by 10, I'll get an average difference score of 1.10. So what I've done so far is I've gotten the sample mean for the baseline scores, the sample mean for the follow-up scores, the sum of the difference scores, the sum of the difference scores squared, and finally the mean difference score. The next thing you want to do is calculate the variance of the difference scores. The formula for calculating the sum, the next thing you're going to want to do is calculate the variance of the difference scores. The formula for calculating the variance of the difference scores is a little bit different than you'll see in most statistics books, but I think this is a better computational formula. The variance of the difference scores is going to be equal to the sum of the difference scores squared minus the quantity, the sum of the difference scores squared, divided by the sample size, and all of that is going to be divided by the sample size minus 1. So for our data, if I want to calculate the variance of the difference scores, I'm going to take the sum of the difference scores squared, which you recall is 47. I'm going to subtract the sum of the difference scores, which is 11. I'm going to score that value and divide it by the sample size, which is the number of pairs, 10. All of that's going to be divided by 10 minus 1, or the sample size minus 1. If I keep doing my work, I'll end up with 47 minus 12.10 over 9. Keep working out that math, and I'll end up with 34.90 over 9, which will give me the variance of the difference scores, which is 3.877. Remember, you want to carry out your intermediate calculations at least 3 decimal places so you don't end up having a lot of rounding error. Now notice this is the variance of the difference scores, but what I really want to obtain is the standard deviation of the difference scores. And you'll recall that we can easily obtain the standard deviation simply by taking the square root of the variance. So we'll take the square root of the variance, which is in this case 3.877, which will give us a standard deviation of the difference scores that will be equal to 1.969. Now that we've calculated the variance of the different scores to obtain the standard deviation of the different scores, we can go ahead and calculate our t-statistic. The formula for calculating a paired samples t-test is going to be the average of the different scores divided by the standard deviation of the different scores divided by the square root of the sample size. So we'll go ahead and plug in our values. You'll recall that the average difference score was 1.10. The standard deviation of the different scores is 1.969. All of that's going to be divided by the square root of 10, representing the sample size or the number of pairs. If we keep working that out, we'll end up with 1.10 divided by 0.622, which will give us a t calculated that's going to be equal to 1.77. So now we've computed the test statistic t calculated. The next step is going to be drawing our conclusions. Now that we've calculated the paired samples t-test, the next step is to draw our conclusions. What I like to do is write down my t calculated, and in this case it's 1.77. I need to determine my degrees of freedom. The formula for calculating the degrees of freedom for a paired samples t-test is going to be the number of pairs minus 1. In this case, we have 10 pairs of scores. We'll subtract 1 because we used one piece of information, so we'll have 9 degrees of freedom. And now I need to find out what my t critical is using an alpha of 0.05 and a one-tailed test. Remember, the reason why we're using a one-tailed test is because we explicitly stated the direction of the effect. We said that there's going to be a decrease in smoking from baseline to follow-up. So now I can go to the back of any statistics book along the tabled values of the t distribution, and for an alpha of 0.05, one-tailed test, you'll see that the critical value of t is 1.83. Now that I've got my t calculated, my degrees of freedom, and my critical value of t, I can draw my conclusions. I'm going to draw which looks like a positively skewed distribution. I'm going to mark off the lowest 5% of that distribution. Remember that the t distribution goes from 0 all the way to infinity. I'm going to put in here my t critical, which was 1.83. If my calculated value is equal to or greater than my critical value, I'm going to reject the null hypothesis. If my calculated value is less than my critical value, I'm going to fail to reject my null hypothesis. You can see that our calculated value is 1.77, so that might be just a little bit less than 1.83, and I'll plot that along the critical value chart. I'll look up and it tells me what to do. Failed to reject the null hypothesis. The next step is going to be writing up my results. So because we're failing to reject the null hypothesis, we have to look right at it. And this will tell us the truth in the world. So what we can see is that in the population, there's no difference between baseline and follow-up scores regarding smoking because of this smoking cessation program. In fact, if we were to collect data on every single person that could possibly go through the smoking cessation program, we would see that their baseline scores are exactly equal to their follow-up scores. The next step is going to be writing up our results. The final step to determine whether or not there's a difference between the baseline and follow-up means is to write up our results. We can find sample language to help us write up our results in the text. Remember, when we're writing up our results, we want to state the statistical test that we did, why we did it, report all of our values, including the t calculated, the degrees of freedom, and the probability that the effect is due to random variation. Using the sample language in the text, we might write up our results like this. A paired samples t-test was calculated to compare the number of cigarettes smoked before and after a smoking cessation program. The mean at baseline was 8.30 with a standard deviation of 3.12, and the mean at follow-up was 7.20 with a standard deviation of 3.04. No significant change from baseline to follow-up was found, with a t calculated of 9 degrees of freedom is equal to 1.77. The probability that the effect is due to random variation is less than 0.05. The current study indicates that the smoking cessation class do not decrease smoking. So the first thing we did is we wrote what test we did and why we did it. We reported our descriptive statistics, and then we reported the results of our significance test. Notice here that we're reporting the test statistic we calculated, the degrees of freedom, the calculated t statistic, and then the probability that the effect is due to random variation. Finally, we have a sentence explaining the result in everyday language. I hope you've enjoyed this video and that you've learned how to calculate a paired samples t-test. Make sure that you always go through those 4 steps. State the researcher's and null hypothesis, perform the appropriate statistical procedure, draw up your conclusions, and then write up your results. As always, if you have any questions, make sure you stop by my office hours.